For most of the world, an aircraft carrier is already a symbol of power. But for the United States, an aircraft carrier is something else entirely. It's a moving airbase, a floating command center, a 100,000-ton political message that doesn't need translation. And right now, that message is sailing into Northern Europe. Because the USS Gerald R. Ford, the largest and most advanced warship ever built, is heading toward Norway, and it's doing it at a moment when the world is watching every move in the Arctic, the North Atlantic, and Eastern Europe. This isn't just another port visit. This is military signaling at the highest level. A ship that looks like science fiction, made real. A ship so expensive, so advanced, and so strategically important that its presence alone can change the tone of an entire region. And what makes this even more historic is that this is the first time in 65 years that a U.S. aircraft carrier has docked in Norway. The last time it happened was July 1958, when the USS Intrepid visited during the Cold War. Back then, the world was divided into two blocks, two ideologies, and two massive military systems staring each other down. Now the world is again entering an era where the oceans matter more than ever. And Norway sits in one of the most important places on the map. It shares a direct border with Russia, around 198 kilometers long. It oversees access to the North Atlantic routes used by submarines, and it sits next to the Gjuk Gap, Greenland, Iceland, United Kingdom, one of the most strategically critical naval choke points on Earth. In simple terms, if the North Atlantic is a doorway, Norway is standing right next to the lock. That's why the arrival of the USS Gerald R. Ford isn't symbolic, it's practical. Because when you bring a Ford-class carrier into Norwegian waters, you're not just parking a ship, you're bringing an entire strike system into the neighborhood. The Gerald R. Ford Carrier Strike Group doesn't travel alone. It brings its own protective bubble: destroyers, cruisers, submarines, and aircraft. A self-contained force designed to operate far from home for long periods of time with enough capability to dominate large areas of ocean and airspace. And during this visit, the timing is not accidental. It comes right before large-scale exercises in the Arctic, involving around 150 aircraft and roughly 3,000 military personnel from 14 Western nations. This is the new security reality. The Arctic is no longer just ice and research stations. It's turning into a strategic highway. And the more the region becomes militarily relevant, the more these deployments become inevitable. Norway's role has also changed dramatically in another way. After Russian gas flows dropped following the invasion of Ukraine, Norway became Europe's largest natural gas supplier. Which means Norway isn't just important militarily. It's also crucial economically. Energy security and military security are merging into one system, and carriers exist to protect that system when things become uncertain. Norway has also supported training programs related to Ukrainian pilots transitioning onto F-16 fighter jets. That kind of support matters. It signals long-term commitment, and in modern geopolitical competition, commitment is everything. Now, Russia can't ignore a Ford-class carrier, and predictably, Russian narratives react strongly when a ship like this enters the region. Because even if Russia doesn't plan to challenge it directly, the presence of a Ford-class carrier removes options, reshapes planning, and forces responses, especially when discussions keep resurfacing about Russia's only aircraft carrier, Admiral Kuznetsov. The Kuznetsov has a long and difficult history. But even with its limitations, it represents something symbolic for Russia, the idea of blue water carrier power. And historically, the Kuznetsov has been used to demonstrate presence, such as during operations near Syria. So, when Western analysts hear talk of Kuznetsov returning to meaningful service, attention spikes immediately, because it would represent something Russia rarely gets to show: a carrier-based aviation capability. And that is exactly where the USS Gerald R. Ford becomes a different kind of opponent. Because Ford isn't just bigger, it isn't just newer, it isn't just more advanced. It is built around technology that changes how carrier operations work. It is one of those machines where you can almost feel the shift between generations. The US Navy didn't design it as an upgraded Nimitz. They designed it as the carrier after Nimitz, a platform meant to dominate a future filled with drones, networked warfare, long-range missiles, electronic attack, and multi-domain operations. And it's loaded with new systems. Not 2 upgrades, not 5 upgrades, but more than 20 major new technologies compared to older carriers. The most important of those technologies aren't weapons in the traditional sense. They're systems that multiply everything the carrier can do. They're force amplifiers. The first one is the Electromagnetic Aircraft Launch System, known as EMALS. This system replaces the steam catapult, a Cold War-era solution, with something far more precise. A steam catapult is powerful, but it's brutal. It slams aircraft forward using mechanical force, and that creates stress. And stress means wear. Wear means maintenance. Maintenance means reduced combat tempo. EMALS changes that equation. Instead of steam, EMALS uses a linear induction motor. In simple words, it uses electromagnetic force to launch aircraft like a railgun launches a projectile, smoothly, consistently, and with programmable acceleration. And that matters more than people realize. Because carriers don't just launch fighters anymore. They launch early warning aircraft. They launch electronic warfare planes. They launch drones. They launch future systems we haven't even seen yet. EMALS can adjust launch power for different aircraft types, reducing stress on airframes while increasing reliability. And the system is designed to go through roughly 4,100 launches before a major fault. That kind of performance turns a carrier into a high-output machine, and output is everything. Because the metric that truly defines carrier power is not displacement, not cost, not size, it's sorties. Sorties are launches, the number of aircraft you can send into the sky repeatedly, day after day. A carrier that launches more sorties controls the tempo of the region. The second major system is the Advanced Arresting Gear, or AAG. Launching aircraft is only half the story. You also have to recover them safely in rough seas, at night under pressure. Old arresting systems were effective, but they weren't built for the future. AAG is designed to handle wider aircraft variety and higher operational cycles. That includes the next era of unmanned aircraft. And like EMALS, it's built for efficiency. Less stress, faster turnaround. Not just landing planes, sustaining an air war. Then there's another surprisingly important system: weapons elevators. It sounds simple until you realize what it means. An aircraft carrier is basically an industrial factory in motion. Bombs and missiles are stored deep inside the ship, and they need to be moved upward constantly. Older ships use older elevator systems. The Ford class uses advanced weapons elevators, electric-driven, faster, more automated, and designed for high tempo. That means weapons can be moved to the flight deck faster, which means jets can be armed faster, which means sorties increase again. And that's the thing about the Ford class. It doesn't rely on one miracle invention. It relies on multiple interconnected improvements that all point toward one goal. Keep aircraft launching, keep weapons flowing, keep the carrier generating combat power. Because in modern conflict, the most dangerous carrier isn't the one with the biggest deck. It's the one that can maintain pressure the longest. The USS Gerald R. Ford also has another advantage: power. Real power. Not military power in theory, literal electrical power. The Ford class uses 2 Bechtel A-1B nuclear reactors. These reactors generate around 25% more power than the A-4W reactors on Nimitz-class carriers. That matters because modern warfare is electric. Sensors, processors, electronic warfare, jamming, radar, data fusion, all of it demands electricity. And the Ford class has surplus energy. This is important not only for today, but for tomorrow. Because future ship defense is increasingly moving toward directed energy weapons, lasers, high-power microwave systems, weapons that don't fire physical ammunition, weapons that fire power itself. A nuclear-powered carrier with massive electrical output is the perfect platform for those systems. So when the Ford enters a region, it isn't just bringing jets, it's bringing the future infrastructure of naval warfare. Now compare that with Russia's Admiral Kuznetsov. Kuznetsov is roughly 1,000 feet long, displacing around 58,000 tons, far smaller than the Ford. Its air wing capacity is also smaller, typically estimated at around 30 to 40 aircraft when fully operational. And unlike Ford, Kuznetsov was designed with a different philosophy. It isn't just a carrier, it's also heavily armed as a warship itself. It carries defensive missile systems, close-in weapon systems, and famously, it was designed to carry large anti-ship missiles, the P-700 Granite. Those missiles are massive. Each one weighs around 15,000 pounds, and their role was to threaten large surface groups. It was an idea built in a Soviet era where carriers were rare, and breaking American carrier groups was seen as a central strategic challenge. But the Kuznetsov has faced serious challenges over the years: reliability issues, maintenance setbacks, accidents during repair periods. And this matters, because a carrier isn't about symbolism, it's about availability. If a carrier is not ready, not deployable, or not able to launch aviation reliably, then it becomes a strategic liability rather than an advantage. That's why Ford's arrival in Norway is so disruptive. It represents a ship that isn't just theoretically capable, it's operationally designed to sustain modern tempo. It's a carrier built for long missions, high sortie rates, deep integration into alliance systems, and future upgrades through its electrical and digital architecture. So when NATO runs exercises involving dozens of aircraft, thousands of personnel, and multiple nations, a Ford-class carrier fits into that ecosystem like it was designed for it. Because it was. And that's the point of this deployment. This isn't just about showing the flag. It's about demonstrating that the alliance can move massive modern power where it needs to be, when it needs to be there. And it's a reminder that the Arctic, the North Atlantic, and Northern Europe are no longer quiet backwaters. They're strategic zones again. This is the kind of moment that defines the next decade. Because no matter where global competition goes next, sea power is back at the center. And in that world, carriers still matter. But only the carriers that can evolve. Only the carriers that can survive. Only the carriers that can keep generating air power, even when everything is contested. And right now, nothing represents that better than the USS Gerald R. Ford. If you enjoyed this breakdown, drop a like, subscribe, and tell me in the comments, do you think aircraft carriers are becoming obsolete? Or are they evolving into something even more dangerous than ever before? Thanks for watching, and I'll see you next time.